Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 31, Sprite Transparency. Transparency refers to making an image slightly see-through or transparent. And there's a number of words which are all kind of related. If something is opaque, that means you cannot see through it at all. For example, a wall is opaque. Something which is transparent is completely see-through. So this would be something like, clear glass. Something which is translucent, light can partially pass through that. And that might cause some kind of a tinting kind of effect. Kind of like water. Water is translucent. So something which is translucent is somewhere between opaque and transparent. Sometimes the words can be a little bit confusing. Opacity and transparency mean kind of the same thing. In this video, we'll learn how to make sprites somewhat transparent. And the code is actually really very short, which is nice. First, let's go ahead and go to our Sprite class in our development environment. So here I'd like to open up the Sprite class. Been adding all sorts of good things to this class. Next, along with angle and mirrored and flipped, let's go ahead and add, I'm going to call this opacity for a reason which will become clear in just a moment. And so the amount of see-through-itness, the amount of opacity used when rendering or drawing this sprite, we'll make that a public double, we'll call it opacity. All right, really the only place we need to alter the code, since this is public, we'll be able to set this value. Let's see, so the opacity, we'll initialize that value to opacity. We'll initialize that value to 1. 1 represents completely opaque, solidly colored sprite. When opacity is set to 0, that will be completely see-through. So the place we use this value is down in the draw method. Right? And the line of code we need, right, after setting the transform and before we draw the image, we will also set the opacity level. And the method we need here, it's a method belonging to the context, since a graphics context object is responsible for drawing things on the canvas. This is called setGlobalAlpha. Now, the reason this is called alpha is the pixels of an image. We sometimes say that the data stored in a pixel are RGB values, representing the amount of red, green, and blue, which are used to determine the color of a pixel. However, in any image format that includes transparency data, that's stored in a fourth value, which is often called the alpha value. It's the amount of opacity or transparency. And the way setGlobalAlpha works is for large values, it creates an opaque pixel. For small values, values close to 0, it would create a transparent pixel. So in this case, a large value is an opaque pixel. That's why we're calling this opacity rather than transparency. Right? When this value is 1, it represents 100% opaque. So that's really all we need to do. If we run Starfish Collector, our game, as is, right, there should be absolutely no changes to this. We should see our turtle and all these other objects, just as before. Now, if we want, we could make these objects appear to be underwater rather than sitting on top of the water. You might not have thought of this a lot up to this point, but I often do. If you look at this picture, it kind of looks like everything is skating on top of the surface of the water, And really, we'd like to think of this as being underwater. So really, these starfish should appear, well, under the water. They should be tinted blue because the water is kind of blue. One way we could accomplish this is by setting the opacity of these different objects. Right? So for example, in the starfish creation loop, so this is in the starfish collector.java class, in the initialize method, when we create the starfish, after we set the texture, we could also say starfish.opacity is equal to 0.5. When we run the game like this, we'll see that the color of the starfish is blended with the colors of whatever is underneath it. And so if we look at some of these starfish up here, right, they're slightly tinted blue, and that makes sense, right? Because the starfish, well, they might be underwater. However, you might notice in the other places where starfish overlap objects, right now, the starfish on top of the shark, you can really tell here that it's the starfish to which the opacity is being applied. It looks like the starfish are made out of plastic or glass, and you can see the shark through them. And that's clearly not the effect we're going for. We could partially resolve this problem by making sure that the starfish do not overlap the sharks or the rocks, but they only overlap the water. But then we would have to go back and we would have to overlap, or we'd have to change the opacity of every object to make it look as though it's underwater. There is an easier way to do this, which we'll do next. Instead of changing the opacity of all these objects, truly it's the water which is translucent. So we'll change the opacity of the water, but not this water laying at the bottom. I'll also add a second water object lying on the top of this scene, and I'll change its opacity. And then the colors of that water will tint everything underneath it. And so I'm going to remove this line of code where I changed the opacity of the starfish. That showed us that the code was working, but it wasn't producing the effect we were looking for. So instead, I'm going to create another water sprite, and I'll change its opacity at the very end. However, I will add it before the win message because I would like text to display above everything else. So let's create a second sprite. Let's call it water 2. Also setting its texture and its position. Right, and if we were to just run it like this without changing the opacity, because of the order in which we're adding this particular water sprite would be rendered on top of everything else and block our view of everything else in the scene. So we do need to change the opacity of this water. Let's set that again to 0.5, which represents 50% opacity. Let's run that and see how it looks. And compiling. Now you'll notice that, well, everything gets tinted a little bit, right? So it does look more like these objects are underwater now. Right, and that might be too much of a tint, right? It does look a little bit strange because I also have these wavy lines going through the turtle. Maybe they don't look strange. I'm not sure. This is really an aesthetic consideration at this point. But if you want, you can change the look of everything just by changing how opaque this object is, right? You can make the water have more or less of an effect by changing this value. For instance, if we change this to, say, 0.10 and run again, right, there's going to be very little effect. This means this top water sprite is going to be so see-through, all the in-game objects are tinted by such a small amount, you really actually can't see it. You can see it a little bit. Maybe you can see some of these wavy dark lines over some of these sprites if you look really closely. If you change this to a much larger value, as the opacity approaches 1, it becomes more and more opaque. It becomes harder to see through. like a very dense fog. It's very hard to see anything. Right? In this case, again, if you look really close, maybe you can see a ghostly image of these different objects. And if you wanted to create ghosts, right, that might be a good approach. So there will be some experimenting, some tweaking of these values to see what you want to set this to get the effect that you're looking for. But that's it. That's how you add opacity. And it has more applications too. In addition to creating something like a water effect, as though the water is on top of everything else and tinting all these different objects, you could also use it to create a fading in and fading out effect, which we'll talk more about when we talk about automated action systems. That's a topic for far down the road. For now, this is probably a good place to stop. Thanks for watching.